to all of you and welcome in the online learning session of B.Sc Agriculture 3rd semester course Biochem 231. Students, in previous class we started new session, that is the water, and we learned the basics about the properties of water, and we learned the properties of water like the expansion or freezing, high heat capacity, high surface tension and universal solvent. And in continuation with previous class, today we will see or we will try to understand the property of water, that is the chemical behavior of water in association with pH. So students, as we know, water as uncharged H2O molecule, but at the same time water can show the slight tendency of reversible ionization reaction to yield the H ion and hydroxide ion. So here the reversible ionization property of water is playing crucial role in different cellular activities, cellular function, and responsible for carry out different biochemical reaction or providing medium to carry out different biochemical and other reaction. So in case of the all chemical reaction, the equilibrium constant is playing vital role. So in case of the reversible ionization reaction of water to yield hydrogen ion and hydroxide ion, the equilibrium constant is playing also crucial role. When the weak acid or weak base is dissolved into the water, so in case of acid release H and responsible for ionization, whereas the H is consumed by the bases and get protonated. So ionization and protonation property is responsible for the providing base for different chemical reaction. So in case of the equilibrium constant, so the equilibrium constant is represented by the reaction. Here the A plus B gives rise to product C plus D, and the equilibrium constant of this reaction is represented here, that is the K equivalent is equal to C into D divided by A into B. So at the same time equilibrium constant regarding the water. So here H2O is responsible for showing the slight tendency of reversible ionization to produce to yield H ion and the hydroxide ion. So in case of the equilibrium constant, so K equivalent is equal to H plus and OH minus divided by H2O molecule. As already mentioned, in case of the equilibrium constant, so equilibrium constant defines the concentration of reactant and concentration of product is at equilibrium level and at specific temperature. So equilibrium constant is fixed and it is constant to all chemical reaction at specific temperature. So in case of pure water, water shows a slight tendency of reversible ionization to yield H ion and hydroxide ion, and only 1 out of 10 raised to 7 molecule undergoes the reversible ionization reaction. So in case of the equilibrium constant of pure water at 25 degrees Celsius is represented in front of you. So K equivalent gives rise to the reversible ionization to yield the H ion and hydroxide ion divided by the water molecule. So in case of the equivalent at 25 degrees Celsius, the concentration of water is 55.5 moles. So how 55.5 moles comes out? So here the gram of H2O in 1 liter divided by the molecular weight. So here the 1000 divided by 18 moles gives rise to 55.5 moles, and this is the concentration of water. So in case of when the reaction is carried forward, so K equivalent gives rise to H plus OH minus divided by 55.5 moles. So the rearranging the equation, rearranging the value, so here the 55.5 moles equilibrium constant gives rise to here is equal to H ion plus hydroxide ion is equal to Kw. So here the Kw means ionization product of water, ionization product of water Kw. So here the reaction again we will see see move ahead or will carry out the reaction. 55.5 moles into 1.8 into 10 raised to minus 16 mole. So now here in case of the K, that is the equilibrium constant, so in case of K equivalent or the equilibrium constant is 1.8 into 10 raised to minus 16. This particular numerical comes out with the electrical conductivity calculation carried out, and as per this electrical conductivity calculation, so here the K equivalent value of K equivalent is 1.8 into 10 raised to minus 16 mole. So here 55.5 moles into 1.8 into 10 raised to minus 16, that is the K equivalent, is equal to H plus OH. H into OH. So here the 55.5 into 1.8, 99.9 into 10 raised to minus 16 moles square, molar square, is equal to H plus and OH minus. So here the reaction again carried out further. So here 1.0, 99.9. So it is again the carry forwarded to the higher decimal, 1.0 into 10 raised to minus 14 molar square, mole square, is equal to the H plus and into OH minus is equal to the ionization product of water. So here the Kw is equal to ionization product is equal to H into OH is equal to the H square, that is the concentration of hydrogen ion. So in case of the concentration of hydrogen ion, as we already mentioned, the water shows less tendency to get reversible ionization, and here the 10 raised to minus 14, that is the only 1 out of 10 raised to 7 molecule shows the reversible ionization reaction of water, fluid, H and OH. So here again the calculation, will carry out the calculation. According to this calculation, here for the calculating value of H, so here H plus is equal to in square root Kw, square root of Kw, so under the square root of 1 into 10 raised to minus 14, so already we calculated here 1 into 10 raised to minus 14 m square. So the H plus is equal to OH minus is equal to 10 raised to minus 7 mole. So this is the value 10 raised to minus 7 gives rise the actual concentration of the H and OH. So at the reversible ionization, then there is a at the equilibrium constant. So the at 10 raised to minus 7, that is the at every 7th molecule or 1 out of 10 raised to 7th molecule shows the reversible ionization reaction to yield H and OH, and at this condition the concentration of H is equal to concentration of the hydroxide ion. So both are present in equal concentration, and water is called as neutral, or the pH is called as the neutral. So how this P and H comes out? So here we calculated the reaction for H ion, that is the hydrogen and hydroxide ion. So H plus H ion. So in case of the H ion, the concentration of H or the potential of H or power of H ion activity, H ion concentration. So this gives rise the reaction. The H plus is equal to hydroxide ion is equal to, as this 10 raised to minus 7 is the constant, or ionization or ion product of water is constant. So whenever the H ion concentration into the solution increases more than 1 into 10 raised to minus 7, so at the same time the hydroxide ion concentration is less than 1 into 10 raised to minus 7. So vice versa, in case of the hydroxide ion concentration increases to greater than 1 into 10 raised to minus 7, the hydrogen ion concentration is reversible, that is lower than 1 into 10 raised to minus 7. So this is the calculation regarding the equilibrium constant and the value of H ion. because the hydrogen and hydroxide both are playing important role regarding deciding the property of water, what actually it is called as the pH, power of H or potential of H ion. So how this pH comes out, who discovered the pH and what is the actual role of pH, that we will study in next class. Students, if you are really get benefited by this video, share this video with the students of B.Sc Agriculture studying in third semester and those who actually studying for biochemistry in detail. And you can like my video on YouTube, you can share this video and you can subscribe my channel on YouTube. If you are facing any difficulty regarding this calculation or any part of the biochemistry, you can contact me on 9421872858. Again this video. Thank you for watching this video.